So this is a presentation on technological change, and I'm really going to go through the in-depth mechanics of how technological change and cost changes can affect cost curves. If you want the slightly more summarised version of this presentation, have a look at the video Technological Change 2, and that will give you more of an overview of what's happening. But this video goes into the depths for those students that really want that extra level of understanding. So these are the parts of the specification we're going to cover, and we're still going to be looking a little bit at the law of diminishing returns and returns to scale, so the economies of scale section, because in there it talks about how productivity and factor prices can affect firms' costs of production and the choice of factor inputs, but we're mainly going to be looking at technological change. And the specification is quite wordy, but if you summarise it down, you get these three key questions. So how do factor prices affect the cost of production? How does invention and innovation affect the cost of production? How does an increase in productivity affect the cost of production? So here we have our cost curves, and this is a diagram showing a monopoly, and we can see already shaded in we've got supernormal profits in that green box there. So generally speaking, an increase in the cost of production or a decrease in productivity, so your inputs are making less output than they were before for some reason, maybe a machine is broken or something like that, but generally speaking, what that does is it shifts your cost curves up. And if you get a decrease in the cost of production or an increase in productivity, or both maybe, generally speaking, this is going to shift your cost curves down. So it does get a little bit more complicated though. If you can, I would be happy with all of my students if they remember that. I think all of my students would remember that. But here comes the more technical part. Okay, so remember when we're looking at costs, so variable costs such as wages or raw materials, so these are the costs that change with output, and the more you produce, the larger these costs are going to be. That's going to shift both average cost and marginal costs. Okay, so if we decrease variable costs, it's going to shift them both downwards. Whereas fixed costs, so a rent or a windfall tax, that's only going to shift average costs. It's not going to affect your marginal costs of production. Okay, so here we have reduced fixed costs on our diagram, so it's just shifting average cost downwards. There we can see, then we have the variable costs reducing, and that's shifting them both downwards. And what's interesting is when we shift fixed costs, shifting fixed costs there, it's going to have no impact on the profit maximizing level of output, because remember, the profit maximizing level of output is where marginal revenue equals marginal cost. So you intersect there, you go right up to the curve, that's your price, and then where it's crossed your average cost, it's where you've got your supernormal profit. So we're actually increasing our supernormal profit here whilst having no effect on the market or the customer, the price the customer's paying. Now, that's a little bit simplistic, because actually what it might do if fixed costs are reducing is it might reduce your barriers to entry. So in the long run, you might find that if it's easier to get into the market, you do get more competition, and actually this average revenue curve would shift to the left a little bit. So we actually might have an impact on the price in the long run. But if the barriers to entry haven't changed, theoretically, all that's doing, that reduction in your fixed cost, is just increasing profit. So that's nice for this firm. Here, when we see average costs and marginal costs decreasing, we find that it's actually changing the price and the profit maximizing output. So this second box representing supernormal profit does actually look bigger than the first box to me, but that would be dependent on your PED, your elasticity. So if it's elastic and the price reduces, we know that that box is going, well, the revenue box is going to get bigger, and therefore that profit box is going to get bigger as well. But if it was inelastic, it wouldn't. So whether profit increases when you've got reduced variable costs depends upon your PED, because it is going to have an impact on your price and profit maximizing output. So that's what happens if we if we decrease costs, and it depends upon which costs are decreasing, whether they're fixed costs or variable costs, or maybe even both. But let's have a look at technological change now, and this has an impact on productivity as well, because usually we invest in new technology, in innovation and inventions, because we want to improve our productivity. So we want to be able to get more output from the resources that we have, and therefore lower our average cost of production. So that's why when I talked about productivity before, it was average cost moving downwards. So I've Googled machinery, and this is one of the pictures that came up, and I'm not completely sure what this does, but it looks very technologically advanced, and it also looks very expensive. So the first thing to know about technological change is usually it requires a fixed cost. It's an investment that a firm makes. So first thing that might happen with technological change is that you actually increase your average fixed costs, but no firm in the world in their right mind, if they're a profit maximizing firm, is just going to want to increase their costs. There's got to be a reward for doing this, or an incentive for doing this. So they're hoping that, or they know that it's going to decrease your average variable costs, and hopefully that benefit, that gain in reducing your average variable costs, will outweigh the increase in your average fixed costs. Okay, so it's going to increase productivity. You should be able to produce more with the resources that you have. So here we have our average costs and marginal costs, and intersecting at that lowest point, that productively efficient point. And what we might find is that we just push down average costs and marginal costs. Okay, so that point of productive efficiency might stay the same. But if the balance, the proportion of the fixed costs to the variable costs making up the total cost change, we get some different things happening. So here we've got this average cost curve and marginal cost curve moving slightly to the right, so the productively efficient point on the average cost curve has moved to the right as well. And this is the case where fixed costs make up a larger proportion of your total cost. So this is usually where this technological advancement has been due to you having better machinery, okay? And remember, this is a factor when we're looking at economies of scale, and especially in the long run, and larger firms being able to afford better technology and all those types of things as well. And, you know, this is what we'd imagine to see, that we would see that the cost curves are shifting like this way downwards. So we're seeing that, and that represents fixed costs making up a larger proportion of your total costs. And this is going to have an implication for your minimum efficiency scale. So we now see the MES is actually increased there. So to be productively efficient, you do have to produce on a larger scale or a larger output. Okay. But sometimes technological change actually decreases your average fixed costs, and it decreases average variable costs, so increasing productivity. So this is a nice photo illustrating this point. So in 2000, that was the iMac that came out, and I actually had one of those in 2000, and I also have an iPhone that looks like that, and it's amazing to think that actually this iPhone is more technologically advanced than this big bulky computer. And also, if you look at the price here, this computer was £1,500, and we see that the iPhone, if you bought it outright, would be just under £600, but has more storage and processing speed and all these kind of fancy things that the iPhone can do these days. So we're seeing, obviously, this is going to decrease our fixed costs, because we can see very clearly it's cheaper, and hopefully as well make us a lot more productive if we're thinking about, you know, a business using these things. So when that happens, what we find is that actually this point of productive efficiency might move to the left, and that's because fixed costs have become a smaller proportion of total costs. So total fixed costs have actually fallen by a larger proportion than the total variable costs in that case. And that has implications for the market as well. It's now cheaper to get into the market. Our fixed costs have fallen, and it's less of a barrier to entry for firms. So we've got the other situation where that actually might increase barriers to entry, and this situation where it's actually going to decrease barriers to entry, and you need to produce a smaller level of output to be productively efficient. Now this curve might not start to increase straight away. It might continue being flat for quite a while onwards. It just depends on what market and the technology and all those types of things. So let's have a look at what happens to the consumer and the market and those types of things. So if I just add in the average revenue and marginal revenue, we can have a look at this. So this would be the first output, the profit maximizing output, because it's where marginal cost intersects marginal revenue. There we go. And that would be the price. And then this would be the second price. We're seeing it lower. So we've got an increase in consumer surplus. So it's going to become more allocatively efficient. And we've got a larger output as well. More people are able to benefit from this product. And actually that second box looks larger to me, but again, it's dependent on PED to whether it is actually larger. And then we've got this first case as well. So I'm adding in my revenue curves, and we've got the first price, and then we've got the second price. And first box, second box, there's more of a difference there, but I think it's just the way I've drawn my curves, to be honest. Again, the second box of supernormal the second box is the yellow box, is representing a supernormal profit, is much larger. But this would be dependent on PED. It must be an elastic demand curve, or elastic at that point. So generally speaking, summary time. Technology means that firms are more productive, so they can produce more with the resources that they have. This does have an impact as well. Just going back to diminishing marginal returns, we can see that the total output that you can produce is actually increased there as well. So this does have an impact for when diminishing marginal returns set in as well. So technology makes firms more productive. This should lower average costs and marginal costs, because it's going to have an impact on fixed costs. It's going to have an impact on marginal costs. It should mean higher profits, no matter whether fixed costs become a larger proportion or a smaller proportion of total costs. However, it depends upon what the technological change or advancement was. So if the MES, the minimum efficiency scale, or the point of productive efficiency, has decreased, and that would be because fixed costs have become a smaller percentage of total costs. So where your technological change has been just that you can buy your machinery for a cheaper price now. The firm that you're buying it from, they can actually manufacture it for a cheaper price. This should decrease the barriers to entry. Okay, where MES increases, so fixed costs become a larger proportion of total costs. So where your technological change has been due to having to invest in quite high-tech, expensive technology, this should actually increase the barriers to entry and higher MES. Okay.